Assalamualaikum and good day to Dr. Yamani and to my fellow classmates. My name is Chairiel Azizi bin Khairuddin.
And hi, my name is Aina Azerin.
Today we will look at Lab 8, which is regarding hierarchical file organization technique. A hierarchical file system is how drives, folders, files, and other storage devices are organized and displayed on an operating system. A hierarchical file system, the drives, folders, and files are displayed in groups, which allows the user to see only the files they are interested in seeing.
Now for the illustration and analogy of hierarchical file organization technique. So first we must know the characteristics of it. So names must be unique only within the collection of files of a single user. Each user directory is a simple list of the files of that user. And last, file system can easily enforce access restriction on directories. So the hierarchical organization technique, we can illustrate it as a tree-structured directory. So before that, we must know the type of operation that can perform in this method. So the first is create, which means we can create the files or we can create the folder in the directory. The second is delete. So when we have create, then the complement of it, we have delete. Yeah, we want to delete the directory or the subdirectory, all the files. And third is list. This basically we can list all the files or the folders in the directory. Last is the update. This means that we can update the files over the, for example, we can rename the file's name. Okay. Now for the structure and illustration. So we have a master directory here. Then we can create a subdirectory. This is subdirectory 1 and subdirectory 2. And then under subdirectory 1, we can create another subdirectory 3 and a file 1. And under subdirectory 2, we create a file 2 and a subdirectory 4. And then under subdirectory 3, we can create another file 3, subdirectory 5, and then a file 4. So the type of operation that we can do other than create is update. So for example, you want to update the file 2 and rename it, so we can do that. Update file 2 become file 0. And then the other operation that we can do is delete. So for example, we can use to delete subdirectory 4 and delete. That is the illustration for hierarchical organization technique. And then another analogy that we can see in our daily life is for file manager. So as you can see here, this is an example of a hierarchical technique. In this picture, we can see that under my documents we have a list of a folder subdirectory here. So for example, under 51 we have another, like for 8 subdirectory. So then under HW we have another subdirectory in here, which is called solutions. So we can see that we also have files here. So this is example for the hierarchical organization technique. So I think this is it for the illustration and analogy.
Now let's look at the flowchart and programming explanation.
Okay, now for the flowchart and coding part for the hierarchical file organization technique. So first we will start by implement tree data structure to simulate the hierarchical file organization. So we will need to provide the necessary method for the tree data structure. So here I'm import the array list and the list library to implement this tree data structure. So here are the code to implement the tree data structure and the necessary method here to get the data, to get the file name, set, get the parent of the file or folder, and add a new folder or file. We will use this add method, and also we can use add children to add sets of folder or files. And then we will make 3 additional methods, which is the find folder, list children, and tree list. So we can see here I have the find folder to indicate whether the file or folder exists in the directory or not. Here the find folder method, and the list children is to list out all the files or folder in a directory. And finally the tree list, which is to print the tree structure, which you can see on the Windows command prompt like. So it will print the tree list. Okay, then we will use buffer reader to take input, initialize the root path using tree data structure, and make a variable to keep track of the current path. So we scroll up, and here is about our buffer reader to take the input here, and then we initialize the root path. So this is our root path, and this is our current path. Okay, then we will go into the while loop. So we will first print the working directory. So you can see here this is our working directory. So I make a method to print this working directory here. Yeah, this is the method to print the current directory. So if you want to see it, I will run this for a moment. Yeah, this is what our directory print is. Yes. Okay. Then we will split the input and do the command processing. So here, as you can see, using the buffer reader, we will split it because we will use the command like make directory, list, make file, or cd, change directory. So this is the command processing. So for example, if the arguments is like I have like the cd, so if it's just the cd here, so it will go to the command.exist because only one argument. So when we have two argument, for example like make directory hello, so make directory which is this is command make directory will be assigned to this part, and we will split it, and the file name will assign to the hello. So make directory hello. Okay, to start the command processing here, we will look into a set of if-else statement. So first, if our command equal to cd, if it is true, we will whether be change the directory into the folder, or we can traverse back to the previous folder. So what I mean here is, okay, we look into the code here. So if command equal to cd and the argument is 2, means that we have the folder or file name after the command. So if our file's name equal to dot and our current path data is not equal to the root path which we have set here, then we will traverse back to the previous folder. Otherwise, if the current path is equal to the root data, then we will it is already in the root, and hence we will print in root. And then if we want to change directory, for example, if we have already created a folder and then we want to change to the folder, so if the folder, maybe you mistakenly spell the folder name, if the folder is not exist, so we will print the folder is not exist. Okay, the file name is not found. Otherwise we will use this find folder, so we will change directory into the folder. Okay, then if it is false, we will move to the statement, which is if command equal to make directory, then we will add folder to the current path. Okay, here you can see here, when command equal to make directory and arguments 2, so we will add the folder to the current path and print the working directory again. Same as if the command is make file, so if it is true, it will add file name to the current path too. Okay, and then if the both folder is also false, then we will go to this statement, which is command equal to list ls. So what we will do here, we will list all the folders and files in a directory. So this is the coding part for that statement. And if it is also false, then we will move to the command equal to 3. So we will, if it is true, we will print the tree structure of the directory. And then here is the part we will print the tree list here. So the tree method that we have defined here, back here, find folder, the list children, and to print the tree list. And if it is also false, then we will move to command exit. Okay, first let me explain about this. If the command is none above of all this, or an empty command, so it will print command does not exist, and we will iterate the loop again. Okay, so here when the command is exit, so we will print exited and exited program. So here is the command does not exist part. If the user input an empty input or invalid command, and here is our break statement. So when the user type in exit, so we will print out exited, and then we will break and stop this program. Okay, now I will run and demo the output here. Okay, so run. So here is our print working structure, and if we just put an empty command, so we will print command does not exist, please enter a valid one. Okay, so now I will demonstrate the make directory here command. So for example, I make a make directory and I input command ls, which is to list the children. So here we have haha. So I make another 2 folders, he and make directory who, and when I ls, so it shows all the current folder in the directory. So for okay, now I will demonstrate the change directory, which is cd. So for example, I want to change to the directory to the he, so I will cd he. Okay, now as you can see here, the current path has been set here, and I am in the he folder, he directory. So from here I can make directory again. For example, make directory tt, and I can also use the make file, which is make file er.py, and you can see here use the list again. Yeah, we can see tt er.py, and to show you to traverse back to the previous one, so I can cd. So I am now at our root path, and we have vls again. Yeah, on this directory we have only haha, hihi, and huhu, so it will show the tt and er.py. So to demonstrate this command here, I am already in root, so it's supposed to print, yeah, I am already in root. So to demonstrate this command here, so I will change directory to non-exist folder, for example ha. So ha not found. Okay, now I will demonstrate the tree structure, how to print the tree data structure. So I will just go to the who and create some files. Oops, invalid. Yeah, so go back, so I can go to cd qq, and yeah, you can see it is working, and you can just make file gg.py and make directory rr. Yeah, we can traverse back using the cd double wipe to ensure we are in the root path. Yeah, we're in root. So when I type in 3, which is here, so we're supposed to show the tree structure of directory. So as you can see here, this is the demo of hierarchical file organization. So you can see here tt and er.py is in the hihi, and under haha we did not have anything folder or file. In huhu we have ww and qq folder, and this qq folder we have dg.py and rr folder. So that is my demo, and you can use exit to exit the program. Okay, we exited. So I think that's all for the flowchart encoding part. So thank you.